Questions 9, 10, and 11 are all so fast I thought I'd do them all together. So number 9, we're supposed to list the transformations of this graph from the parent graph 4 to the x. I do want to point out that this 4 and this 4, they don't really affect the transformations. It's just that they're going to match because we're taking this graph and we're transforming it using all these other things that are happening to it. And it's the same rules we've been using pretty much all year. Like, for example, this number up here with the x affects that left-right motion, but the opposite of the way you would think. So I know this graph goes left 1 unit. This -3 here is going to affect the y value, and it goes the way you might expect, so it'll be down 3 units. And then this 2 that's out in front is the stretch factor. So we'd say stretched by a factor of 2. And that just means every y value, whatever it would have been, it'll be twice as big by a factor of 2. There we go. For the next equation, we're going to write the asymptote and say the domain and range. The asymptote is this boundary line that the graph approaches but never reaches, so it levels out there. You just draw a line there. If you say just 2 as your answer, that is incorrect, because 2 is like how many apples I have in my bag, or how many homework assignments I have to do. I need to find an equation for a line. So you really need to say y equals 2 to get the correct amount of points for this, because I need an equation of a line, not just some number. As far as the domain goes, I can go left forever, and even though it looks like as I go to the, I can go right forever. And as I go to the left, it looks like maybe I can't go to the left forever, but you really can. There's not a value for x you can't plug into this function. So that domain is pretty much always all real numbers. And the range, I can definitely go up forever. As I start to come down, this whole asymptote, the whole idea is that we approach it, but we never really reach it. So basically, I can go up forever, but not down forever. I can never reach or be lower than 2. That's my range. Is the graph from number 10 decay or growth? Defend your answer. Well, this is definitely a decay graph, and that is because it decreases as x goes to the right. It's decaying. It's getting smaller as x gets larger. That's my defense. Good luck.